Today we'll have our first programming lecture. Let's start by getting the data. So I want you to open a browser, preferably the one that would open an Anaconda Jupyter as well from the previous lecture. Go to github.com/lingbingo. So basically it's my first name, my middle initial, and my last name. And hit enter. Go to repositories and click on the Intro to Programming Python repository. At this point, you can click on Clone or Download and go ahead and select Download a zip file. Save it. I'll go ahead and save it to desktop. And it's right here. Right click on that, go to extract depending on what you have, but go ahead and extract to Intro to Programming Python. So this is what we have. Click on this URL here and you will see the path. Now let's open Anaconda. Let's go to Anaconda and click on Anaconda Navigator. Let's click on Jupyter Notebook. Oh, okay, and show again. Click on Launch. Now we have opened Jupyter Notebook. When you open Jupyter Notebook, this actually takes you to the home directory on your Windows or on your MacBook or on your Linux machines. So for example, if I click on this Lingbingo, you will see that the directory that I have in here, let me sort that alphabetically, and look at that. 3D object, Ansel, BuzzRC, contact. These are the directory that we have. So at the very beginning, Jupyter opened a browser to look into the content of your home directory. So I know that I saved my data to desktop, so click on desktop. And then click on Find Intro to Programming Python Master. And go ahead and click on Intro to Python 1.ipynb. This is the famous Jupyter Notebook. If you search around for data science and Python and Jupyter, you'll see that Jupyter with Python, the Jupyter Notebook is a very popular tool in data science and data analytics. So, as part of this class, we are going to learn how to program. And typically, when you think of programming, you will think like, what is programming? How can I program like a computer scientist? How do I learn and understand the theory behind programming? Blah, 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 blah. Within this class, we really don't want to focus on that. The true learning objective of this class is how can I process data and how can I do it using Python. We will not worry about the theory, the fundamental, the computer science knowledge. For this class, we will be very hands-on and we will learn Python and programming from the perspective of a user. We want to know how to use the tools. We don't need to know how the tools are built or designed. Maybe we need to know some of it, but it will be very limited. The reality is most of us already know how to program. What you have done so far within your work, your career, you have already done programming. It is just that you are not aware that it is also called programming. For example, we all have worked with Excel before. Let me go under the data directory and open the file grades.excel. So I have a list of students and I have a list of their final exam grade, and I want to know whether they pass or fail. I could go and look at the number, and let's say above 70 is a pass, below 70 is fail. So I can go in and I can manually type in, for example, for 92, this is pass, for 85, this guy pass, for 65, this guy suddenly fail. But this is going to take a long time. Imagine I have a class with 50, 60, maybe hundreds of students. This is going to take a very long time. So instead, within Excel, I can put in an equations. This is an equations for Excel that say if B2, so if the value within this cell B2, is greater than 70, then value if true is pass, value if false is fail. So you can see the highlight of the equations over here. If logical test, value is true, value is false. This is Excel, and it is also a form of programming. You are telling a program to do what you want to do, and that is programming. So we have all been programming, maybe under one form or the other. So now we just need to learn programming again from a different perspective. So at the very beginning, there are something that, for example, when we did programming in Excel, we have taken for granted is that Excel hid a lot of this nuisance for us. And what we need to know now is what are those and how are they called. So the most important thing in programming is the concept of variables and variable assignment. So let's look at this cell. So in Jupyter Notebook, you can have multiple types of cell. In Jupyter Notebook, each of this, you can see the highlight is called a cell. And a cell can be of multiple type. This is the markdown cell, and this is the code cell. We'll go into the detail of that later. So just know that the code cell is where you can actually write the programming code and execute them. To execute the cell, you can hit the run button. The cell will run. The numerical value here highlight the order of the executions. So in Python, when I type some equation in, it's going to calculate and give me the result. This is nice and all, but it is not critical. If I want to do this, I could have just used a calculator. So that brings up the idea of variable. Variable is a name, a label of a value. Think about your name, your social security number, your driver license, and so on. So in this case, often for a variable it is assigned on the left and the value is on the right. In this case, I am assigning a value of 60 to variable weight underscore kilogram. The equal sign here means an assignment. So when I run this, nothing happened yet. I can also assign weight in kilogram. This is another value, but this time it's a text value. Can be assigned to a variable named weight underscore kilogram underscore text. So then, if I type weight underscore kilogram, what I get back is the value that was assigned to this variable. This is a float value. Similarly, I can type weight kilogram text. I get back the string that I was assigned in cell number 3. And so also side note, The numerical here allow us to refer back to the cell, and also we know exactly the order of execution that we have gone through. And weight kilogram text is type string. In Python, variables name can include letter, digits, and underscore, cannot start with the digits, and are case sensitive. So what do we use variable for? We use variables to help us express logical thinking about the sequences of actions in a programming language. So think a bit about this. Let's take one step back, because the concept of variable is a fundamental and a very important one. Let's go back to our Excel notebook. So we know that the final score for Brian is 85. That is the actual value of his final score. We all know that. But from the perspective of the Excel notebook, 85 is the value of a cell that is at position column B and row 3. And when we want to program for Excel, when we want to make a logical sequence regarding the final score of Brian, we need to point to this value 85. Let's say over here, for example, let's say this cell, instead of using B2, let's say I use 92. My result is still correct. But here's the catch. Let's say I want to take this and I want to apply it to all of the other score. You can see now, when we use an absolute value in our logical thinking, it becomes rigid and it's no longer applicable to a range of variables for a range of different type of data. So in this case, we need some sort of label, of generic common label. So in this case, it is not 92, but we want to refer to the value contained in this cell. And once we have that, and we'll make the copy, the label is going to be able to change and is going to be able to point to the correct value as we move the calculation through the different cell, different rows of the Excel sheet. Similarly, that is the idea about the variable. We use a variable as an abstraction. We use a variable basically as a label in our logical thinking. If you are a student, you have certain right. If you are a faculty, you have a certain different right. If a student's grade is greater than 90, he's going to get an A. If a student grade is greater than 85, he's going to get a B. And this type of logical thinking is applicable across all different students, across all different faculty, across all different value of a variable. So for example, going back for this example, I can print out the weight in kilogram and the weight in pound, which is the calculations by taking 2.2 multiplied by the variable. And now, even if I change my weight in kilogram, this is my result, and then I can go back and I run again. And, oh, I did not change the value. Let's say I change it to 100. So all of the subsequent calculations using the variable is changed, and we only need to change the value at one location. You might note that when I'm running this, my mouse is not clicking on the run button. So there are two additional components that we can use to execute a cell. If you hit the combination of Shift and Enter, you will execute a cell. And then you will notice that we have moved to the second cell. You can also use Control-Enter, which execute a cell but keep the focus on that particular cell. So that was the first lecture. on variable and on Python, and basically how to work with a notebook. Let's go ahead and open the second example. The second notebook, sorry, Introduction to Python 2. Again, our learning objective is still how to process data in Python. So let's think about it this way. If we want to process data in Excel, we need to load data into Excel. So similarly, if we want to process data in Python, we need to load it into Python. And I would like to introduce you to a Python library called Pandas. This is a very, very famous and popular library in Python. This is used to load and process data. So a library is a collection of functions that are designed to add additional functionalities of a specific purpose to the basic Python package. And a Pandas stands for Python Data Analysis Library. It's an open source library that provides high performance and easy to use data structure and data analytic tools for the Python programming language. Now let's see how does that work. So we want to study a data set called combined. It is a comma separate data set. So let me open a new workbook in Excel. And let's go ahead and import that. I'm going to go to desktop. This is delimited using comma. So let's look at this data set. This is a data set imported in Excel. You have the column ID, you have the different column, you have empty cell. So this is how we do it in Python. And then we have a lot of data. We have, look at that. We have 38,000 rows. So as we are scrolling through that, it starts to feel overwhelmed. So let's see how Python can help us do this. To use the library, we first need to import this. So this very first cell, import Panda, will load the library into Python. When you see the star here, that means the Python is still running. It is not ready yet. Only after this turn into a numerical value, indicating that all of the codes in here have been successfully executed. So we use Panda. Panda has a function called readCSV, which we only need to point to the path. So recalling that we are in here, we are in Intro to Python Programming Master, and our data is under data combine.csv. So I just need to specify the path to the data. One thing that Jupyter does very nice is, let's say you don't remember where your data is, you can just hit tab, and you can see it will show up. So this is data, tab again, I can start typing, and it will show up. So combine.csv. Let's run this, and wow, it showed the data just like it did in Excel. All the way, well, it's not exactly, it got up to 29, and then it hit the data, and then it printed out the rest of it. So it tried to show me some of my data, and basically I am not able to use it for anything. At this for Excel, I can still use the code. There is no function box, there is no functionality here in Jupyter for us to do something with this. This is just a display. This is equivalent to someone print out a CSV and give it to you. Nice, but useless. So we need an identifier. We need a variable for this data so that we can use it to manipulate the data. So now the value is on the right side. The values are all of the data that we want to load here, and we need to assign it to a variable. Let's go into variable data. So let's execute this, and then we run data again. it's still printing out something. But as you will see, because we have the value stored in a variable, we can now manipulate the variable. So what is it? What is this data that we have loaded the compiler CSV file into? So the next one, we want to print out the type of the data. So class pandas core frame, this is a data frame. Pandas data frame is one of the two core data structure in pandas. The other is series. Conceptually, data frame is equivalent to an Excel spreadsheet. You can see the similarity here. Even though this is not displaying everything, you can see that we have the column ID, we have the individual value on each row, we have different type of value. We can have number, we can have string, and so on. The only thing different is that we don't really have the column name A, B, C, D, E, F, G, H, I, J, K, L, M, and so on here. We don't have that. And secondly, notice the index for pandas or for Python or most of the programming language in general. Everything starts at 0. The very first index is 0. On the other hand, the first row of Excel starts at 1. So that is the key difference. Data frame represents a table whose columns are vector with the same length with possible different data type. You should be note this. You need to pick the right tool for the jobs. We are learning programming with pandas, but sometimes Excel is the best tool. Using Python and pandas will give you more powerful functionality, but it requires you to have a different perspective in thinking about data. You will lose the physical interaction with data. You will lose the ability to select like this. It's gone. You don't have a mouse control over your data. You don't have the ability to use the arrow to go through and go to the cell that you want to go to. You lose all of that. You lose all of the physical and most of the visual interaction with your data. Instead, you have to think about your data from a different abstractions level and then ask Python to show you. So think Amazon shopping. You know that Amazon has an extensive collection of shoes. You are not going to be able to browse the shoe on Amazon like you would in, say, Foot Locker, Payless shoe, and so on. You are not going to be able to walk through the row and look at this physical shoe. You kind of have to know what you want. You want a men's shoe, you want a size of 11, you want winter boot, and so on. So that's what programming, that's what data analytic in a programming environment is like. However, again, similar to Amazon, Python is going to give you some predefined tool to perceive and imagine the layout of the data. The very first is info, data.info. It tells me the structure of my data. It is a data frame, 34,786 entries, meaning 34,786 rows. Counting from 0 to 34,785. It started at 0, not at 1. I have 13 columns of data. Record ID, month, day, year, plot ID. Int 64, meaning that this is an integer. 64 stands for the bit length of the integer. We don't need to worry too much about that. You can see it here. So record ID, month, day, year, plot ID are all numeric. And then you have species ID and size. They are string, but in this case they are objects. Hind foot length and weight, they are float 64. My guess is, because let's look at this. My guess is maybe because some of the missing value in here that might get this converted to a float value. So float here basically mean value that potentially have decimal point behind it, where it also potentially a float value. Going back to genus, species, taxa, and plot type, they are all objects. In this case, also meaning string type. I can also run data describe. Basically, it would look at all of the numeric and give me back the count, the mean, the standard deviations, minimum, 25%, 50 percentile, 75 percentile, and the maximum value. So describe give me descriptive statistic of all of the numerical column within my data frame. I can look at my shape. So I know that I have 34,786 rows, 13 columns. I can extract just the row, or I can extract just the column. I can use a function called head to look at the first 5 rows, or I can specify how many rows from the beginning I want to look at. I can also specify how many rows I want to look at from the end. And then if I want, I can just look at just the number of column names alone. This is for in the case that I have data that have too many columns. That look at both the columns and the values at the same time is not feasible. And now that we know about the structure of the data, we can also select individual data subset. This is called indexing and selections. So I can select a specific column. So by using data, a square bracket, and this is a nice thing. This is record ID. I don't need to remember. So for example, recalling an Excel, in order to access a specific column, most of the time the typical way is to remember the alphabet value. So quick tell me, what letter represent taxa? Well, we don't know, but we know that it's named taxa. So now you don't need to know. And for example, think about, let's say if you have too many columns and you have to go into double character column type. Instead of having to remember that, you only need to remember the column name. So record ID, month, day, year. This is more likely for us to remember. So I run that, and that gives me back that specific column. I can also select a specific row. This is getting the data at location 0, meaning the very first row, record ID is 1, on July 16, 1977, plot ID 2. This is a rodent. I have no idea what animal this is. You can also slice it, looking at row from 5 to 10. And this is row 5 to 10, 5, 6, 7, 8, 9. So 5 to 10 meaning that it starts from row 5, but it stops just before row 10 to get the data. So this allows you to slicing and dicing. And then there is a lot more about how to select an index data frame. If you follow this link, it will take you to a very extensive document showing you how to do everything. For the sake of simplicity, we will touch on specific approach as necessitated by our data mining task.